Welcome to the lecture on the course Descriptive Statistics with R software. In the last couple of lectures, we have understood that how R is going to be useful for doing various types of mathematical operations, and we also understood that how the missing data values can be handled inside the R software. Now, in this lecture, I will try to give you an idea that how to handle matrix in R software. So, what is a matrix? If you try to see from the mathematical point of view, a matrix is simply a rectangular array which has got p rows and say n column, and this will be denoted as a matrix of order p cross n. For example, I can always write a matrix like here x is equal to, that is the standard notation, x11, x12, say here x1, say here p, and say here x21, x22 up to here x, say n1, and x22 here, and something like here x2p, 2p, and then xn2, and say here xnp. Right. So, this is here a matrix, and what we are going to assume that here all these values are some numerical value, they are some real values, right. So, I will say that all these entries in the matrix are some numerical values, they are currently some real number, right. And in case if I want to denote a particular element, for example, if I want to denote this x12, so x12 is going to be denoted like x1 comma 2. So, that means this is the element on the first row and in the second column. So, a question arises here, what is the difference between data vector and a vector in terms of matrix theory? Data vector is a data vector, but in a matrix theory we have a number one different commands and it has a different structure. So, first you have to decide that whether the data has been inserted in the form of a data vector or in a form of vectors and matrices. Both these operations are going to be different. That is what we are going to see in the further lectures. So, the first question comes, how to create a matrix. So, in order to create a matrix, we have a command here matrix, matrix, and inside the bracket you can see here I am writing here several things, n row, n col, data. So, this n row is trying to give me the information that how many rows I want. So, this is giving us the information on number of rows. N col is similarly, it is trying to give us an information that what are the total number of columns in the matrix. And what data has to be given? This has to be given using the C command inside the data vector, that has to be arranged inside the matrix. So, here if you try to see, I am using here n row is equal to 4, that means the number of rows are here 4. And number of columns, this is here 2. So, there are going to be 4 into 2, that is 8 values in the data vector. So, I am trying to write those values here 1, 2, 3, 4, 5, 6, 7, 8. So, now the data is going to be arranged in 4 rows and 2 columns. So, you can see here there are 4 rows 1, 2, 3, 4, and there are 2 columns here 1 and 2. And data is going like this 1, 2, 3, 4. And then from here 5, 6, 7 and here 8. So, yes, there can be a question that why this data is going to be column wise or why it cannot be row wise. So, that I will try to address, but here at this moment I would request you please try to observe how the matrix has been created. I have simply given the number of rows, number of columns and the data, and based on that a matrix of order 4 by 2 has been created, right. And just for your remembrance, the parameter n row defines the number of rows in a matrix, the parameter n col defines the number of columns in a matrix, and the parameter data defines what data has to be given inside the matrix. right. And usually in case if you are not giving any option whether the data has to be entered in row-wise or say column-wise, the default is column-wise, as we have seen in the earlier slide. So now I am going to consider here the same matrix here X, which I have just denoted, and suppose my issue is this, suppose my query is this, I want to access a particular element. So how to obtain a particular element? Suppose I want to obtain this element 7. So now what is the address of 7? The address of 7 is this. This is located in the third row and second column. So I will try to write down here the name of the matrix small x, and inside this square bracket I will try to write down the address. So in this case, this address is going to be x bracket 3, 2. And once I try to type x 3, 2 on the R console, I will get here the value 7, which is the same value here like this. So before I go further, I would try to show you that how the things are going to happen on the R console. So I will try to create the same matrix here, and you can see here this is here the matrix X, right. And suppose if I want to obtain a particular element, say 3, 2, I am getting here 7. So this 7 correspond to this thing. Similarly, if you want to find out the, see here 2, 2, this is 6. But if you try to find out here 2, 7, you can see here that this value does not exist here, right. Okay. Now I try to address here the second issue, that in case if you want to enter the data row wise, then what option you have to give? You simply have to give an option here or add a parameter here by row is equal to true. So you can see here, mean all other part of the syntax is the same what we use in the earlier slide, but I have used here one thing, by row is equal to true. And in this case you can see that data 1, 2, 3, 4, 5, 6, 7, 8, this is going to be entered like this 1, 2, 3, 4, 5, 6, 7 and 8. Right. So this is how we try to do, and this is the screenshot. I will try to show you on the screen also, on the R console also. And similarly, in case if the data has to be entered column wise, then I simply have to add the parameter here by row, and which is now here false. That means I don't want the data to be entered in the row wise mode. So obviously once this statement is false, then the opposite is true, that the data has to be entered by column wise. So in case if I try to execute these things over the R console, I can show you here. So if I try to use here by row equal to here false, rather I should denote my font size here so that you can see it here clearly. Yeah, you can see here, you can reduce this font size here, and you can see here that this is here by row is equal to false, right. And now in case if I try to see what is here x, this is the same thing. But now in case if I try to do the same thing, and if I try to make it here true, or I can use it capital T also here. Now you can see what is the outcome here. The data here in the first case and the data here in the second case, these are arranged in a different ways. First in the case of column wise, and then the second case it is row wise, right. So this is the screenshot of the same operation for your information only. And similarly, if I want to find out the transpose of a matrix, what is the transpose of a matrix? When we try to interchange the rows and columns, then it is called the transpose. For example, if I say I have here a matrix here x is equal to 1, 5, 2, 6, 3, 7, 4, 8, then this matrix can be given in R console using this command matrix and by the same command that we have used earlier, and its outcome will like this. Now in case if I want to find out the transpose, the command to find out the transpose is here Tx, T means here transpose, and inside the bracket you have to give the name of the matrix of which you want to find out the transpose. So you can see here your earlier this matrix was 1, 2, 3, 4 and then here 5, 6, 7 and here 8. But now this number of rows and number of columns are changed. Here the number of rows are here 4 and number of here columns are here 2. But now once I try to find out the transpose, the number of rows they are here 2 and number of columns here are here 4 and the data is now say 1, 2, 3, 4 and then 5, 6 and then here 7 and here 8. So this Tx is the command to find out the transpose of a matrix in R, and now I will try to show you on the R console also. For example, if I try to take here the same matrix that we had taken earlier. So here you can see here this is your here X matrix, and if I try to find out the transpose of here T of here X, now this is here change. This first row this becomes first column, second row here becomes second column, third row here becomes third column, fourth row becomes here fourth column. So this is how we can find out the transpose of a matrix. Now next I try to address that how we are going to use the operations of matrix addition and subtraction in the matrix setup. So we know that in matrix, if I have a matrix like here 1, 2, 3, 4 and if I try to multiply it by here a scalar 5, then this operation is done on each and every operation, say each and every element. So 1 into 5, 2 into 5, 3 into 5 and 4 into 5. And now in case if I try to make it here the multiplication of a matrix with another matrix, then this is given by 1 into 5 plus 2 into 7, 1 into 5 and 2 into 7, multiply it and then add it, then again 1 into 6 plus 2 into 8, 3 into 5 plus 4 into 7 and then 3 into 6 plus 4 into 8. So this is how the multiplication is done in mathematics, and this is what is taught to all of us. So now in this case I try to take here the same matrix here, which is here in which the data vectors are 1 to 8. And now in case if I try to multiply this matrix by here 5. So the operator what you have to learn here is star. This is the same operator what was used for multiplication. So remember, when you are trying to multiply a matrix by a scalar, then the operator is only star. When you are trying to multiply matrix by a matrix, then I will have a different operator. So in this case, if you try to see here, if your X matrix is like this and if you try to obtain here 5 into X, then you can see here that this element is multiplied by 5, this element is multiplied by 5, this element is multiplied by 5 and each and every element is multiplied by 5, and here you are getting the outcome 1 into 5, 3 into 5, 5 into 5, 7 into 5, 2 into 5, 4 into 5, 6 into 5 and 8 into 5, that is 40. And here is the screenshot of the same thing. So I will try to show you here it on the R console also. Right, you can see here this is your here X, and now you are trying to make it here 5 into X. So you can see here that every element has been multiplied by 5. And now I am trying to consider the multiplication of a matrix by a matrix. So you already have created a matrix here X, and you already have created a matrix here transpose of X, that is already there. So I would like to utilize that thing, right. So now I am trying to multiply the transpose of a matrix X with matrix here X, and now you can see here this is the operator. So this is a matrix and this is a matrix. So when you are trying to multiply a matrix by a matrix of suitable order, then you have to use the operator percentage, multiplication and percentage. And remember one thing, means all those rules for the matrix multiplication from mathematics, they have to be satisfied here. For example, if you have here two matrices A and B, they can be multiplied only if their orders are like this. If A is of order m cross n, then B has to be of order of say n cross p. So these two orders have to match, otherwise this won't be valid. So this is how we try to do it here, and just I would try to show you on the R console also. And if I try to show you here, so this you can see here x dx will come out to be like this. Now I will try to take here some more example to make you understand. And suppose I try to take here, say here two other matrices, which are just matrices of order 2 by 2 and whose data values are 1, 2, 3, 4, and the data has been entered by using the parameter by row is equal to true, right. So in case if you try to insert that data, this outcome will come out to be like this here. There are two rows, 1, 2 and two columns, 1 and here 2. And the data here is entered by row 1, 2 and then 3, 4. And similarly, I try to take another data set 11, 12, 13, 14, and on the similar lines I try to create here another matrix of 2 by 2 and I call it here as a Z. So this matrix will look like this. The data will be 11, 12, 13, 14. And so now I have here two matrices of order, this 2 by 2, and I will try to show you that how to multiply them. So, right, so you can see here there are two matrices here y and here z, and if I try to multiply here y percentage star percentage z, you get here like this. Right. Yeah, and here is the screenshot of the same operation for your understanding. So this is here, right, and this is again the same screenshot which has been obtained over here, right. And now after multiplication, I would try to address the addition and subtraction. Addition and subtraction is quite simpler in the sense that you have to use the same operator that you had used earlier. For addition, you simply have to use the plus operator, and for subtraction you have to use the minus operator. But again I would repeat that all the rules of matrix operation, they have to be satisfied here before you try to do any matrix operation. And this is pretty common that once you are trying to handle a complicated structure where you are trying to deal with various matrices, many times the orders of the matrices do not match, and this gives you a error that you have to actually see what is really happening. So just be careful. So when I am trying to add here two matrices here A and B, I will assume that they have got the same order, say m cross n, and I am trying to subtract here two matrices A and B, I will assume that they have got the same order. That means the same number of rows and same number of columns. Now I am trying to consider here the same matrix which I had created earlier, and you can see here that this was another matrix which I had created 5 into x. So now I have here two matrices here x which is of order 4 by 2, and then I have here another matrix here 5 into x which is of order of 4 by 2. So I can add it together. So now I try to add x and 5x, and you will see here that what will really happen, that all the corresponding elements of x and 5x will be added. And similarly, in case if I try to do here fraction here, then what will happen, that the corresponding elements of the two matrices will be subtracted. So using the plus operator I can do addition, and using the minus operator I can do subtraction, which is pretty straightforward, right. So I can show you here on the R console also. So now let me take here one more example of the same matrix y and z that we have created earlier to show you the addition and subtraction operations. So if you try to see here, earlier I had created these two matrices y and here z of order 2 by 2, The y was order 2 by 2, z was order 2 by 2 using the data set 1, 2, 3, 4 and 11, 12, 13, 14. Now, in case if I try to make it here addition, so you can see here, rather I can show you that 1 and 11 will be added, 2 and 12 will be added, 3 and 13 will be added, and 4 and 14 will be added. And the same thing will happen to the subtraction also. Right. So, these are here the operation. If I try to use here an addition operator, and if I try to use here a subtraction operator, the two matrices of the same order have been added and subtracted. Right. So, before I go further, let me try to show you it on the R console also. So, you can see here, okay, first let me go through here X, and you can see here this was here matrix X, and now you want to do it here X plus 5 into X. So, this is here something like this, and if you want to see here 5 into X is what here. So, it is like this. So, you can see here that X and 5X are added together, right. And similarly, if you try to see here, this is your here X, and if your 5X is like this, and now I try to make it here 5X minus X subtraction. So, you can see here that the corresponding elements have been subtracted, and if you try to make it here X minus 5 into X, means again all the values where the negative sign will occur. And similarly, if you try to recall, I had created this Y matrix and Z matrix. So, I can make it here Y plus Z. You can see here this is like this, mean the corresponding elements are added, and if I try to do subtraction Y minus Z, then the corresponding elements are subtracted. So, you can see here that it is not really a difficult operation. Now, I would like to address here another issue, that once you are trying to deal with the vectors and matrices, then sometimes you need to access a particular part of the matrix. That can be a particular row, that can be a particular column, or that can be a particular submatrix. Then how to do it? So, I will try to show you here. Suppose I try to create here a matrix which is the same matrix which I have created earlier, and suppose I want to access the third row. So, my matrix has been given by, say, by the name X 1, 2, 3, 4, 5, 6, 7, 8, and I want to use here or call the third row. So, in that case, I simply have to write down the name of the matrix, and then I have to write down the address. Address, you can see here, this is the address of row, and here this is the address of column, which is actually here blank. So, as long as you give the address to be the blank, this will indicate R that the entire row is needed. So, and it is not difficult to remember, because if you try to see this 3 comma blank inside the square brackets, this is the same address which is given over here. So, that is not even difficult to remember. Sometimes people do get confused that where to put the blank, on the row or on the column. So, do not hurry for these things. You simply look in the matrix and try to look into the row or column that you want to access, and simply try to give the same address in the as given in the matrix. And similarly, in case if I want to access the second column. So, second column here is like this, you can see here, it consisting of the values 2, 4, 6, 8. So, again the address of the column here is given here as a blank sign, comma, and then 2 inside the square bracket. So, I can write down here the same address over here, say here matrix name, and then inside the square bracket, this is here the row address, which is here left as blank, and this is here the column address. Right. And this value will come out to be here 2, 4, 6, 8. Yes, here you have to be a little bit careful that I am trying to call the second column. So, ideally this should come like 2, 4, 6, 8, but this does not happen in R. If you want to call a row, or if you want to call a column, the outcome will look similar. But whether you are calling a row or a column, that can be accessed only by looking at the command. Whether you have said x inside the bracket blank space comma 3, or you have said x inside the square bracket 3 comma blank space, right. And I will try to show you it on the R console also, but before that I may show you something more. That suppose I want to recall or access a submatrix of a matrix. Submatrix of a matrix means a particular section of a matrix. Suppose I want to find out from the same matrix, I want to recall this part only, and this part has to be left, means I do not want to call it. So, this is the submatrix which I want to call. This is pretty simple. Always remember one thing, whatever you want to recall, just try to give the correct address, right. So, I can use here x, and now I have to give the address, the rows and columns which I want to choose. So, I am trying to choose here the rows 1, 2 and 3. So, I can give it here 1 colon 3, 1, 2, 3, and what about the columns? I am trying to choose here 2 columns, first column and second column. So, I am trying to use here 1 colon 2, and this is my address, and as soon as I try to write down here and enter on the console, I will get here the same matrix here. So, this you can compare, this is the same matrix and this is the screenshot. So, I will try to show you these things on the R console here. So, I will try to take it here x, this is the same matrix that we had considered earlier. Now, suppose I want to recall the second row. So, you can see here I am simply not typing anything after this, after the comma, and I will get here the second row 3 and 4, you can see here. And similarly, if I want to find out here the fourth row, this is here 7 and 8. And similarly, if I want to find out here first column, then I have to leave it here blank or do not type anything, comma 1, and this will give me the first column 1, 3, 5 and 7. But again you can see here that this structure and this structure, they are the same. So, you will not be able to look or you will not be able to decide whether you have recalled a particular row or a particular column, but by looking at these addresses or the structure of these addresses, I can always find out whether I have recalled a column or a row, right. Similarly, in case if I want to find out the submatrix, suppose I want to find out a submatrix consisting of first 3 rows 1, 2, 3 and 2 columns, first and second column, then you can see here I am getting here the same thing. And similarly, in case if I want to find out here only the first 2 rows and first 2 columns, then means I can give the row address to be row number 1 and 2 and column number 1 and 2, and you will get here the same matrix from here. You can see here this is the submatrix what you have obtained. Suppose I want to find out another submatrix which is consisting of the third row, fourth row and first column and second column. So, I can write down here x inside the square bracket 3 colon 4 and the number of columns 1, 2, 2. And so, you can see here that you are getting the 5, 6, 7, 8, and this is the same matrix here which you have obtained here, right. So, similarly, I have tried my best here to take or consider only those commands related to the matrix theory which are going to be useful for us, but beside those things means most of the matrix operation are possible in R, and built-in functions are available. For example, if you want to find out the inverse of a matrix, there is a command solve, S-O-L-V-E. But this list is very, very long. So, I would leave it up to you that whenever you want to use a particular operation related to matrix theory, please try to consult a book or the R software help menu and try to see how that matrix operation can be done. And I would like to stop here, and I would request that you please try to make more practice so that you get more conversant with these things. And from the next lecture, we will start with the statistics part. So, you enjoy the course, practice it, and I will see you in the next lecture. Till then, goodbye.